Hi there. Okay, so I wanted to go through this formative assessment with you guys and make sure you understand everything that is happening. I wanted to record it just so you would have a resource that you could go back to and watch. You could watch it again instead of me just explaining it in a live class. So let's just go through this one by one. So we've got a scaled copy of a big H figure. It goes from big to small. And the first question is asking us to show a pair of corresponding points and then two pairs of corresponding sides. So let's do the points first. And remember, corresponding means they occupy the same place in the figures. So what I mean by that is if I draw a point here, so say that's point A, okay, that's in the top left corner of my H. So when I go over to my little h, I have to also go to the top left corner, and that's my corresponding point. I'll call it A prime. I'll put a little dot tick mark there. It's called A prime. Okay, if I wanted to show another corresponding point, just to show you guys some more examples, maybe this little bottom corner of the middle part of the H, I'll call that B. Well, that corresponds to the little bottom corner of the little h, and I'll call that B prime. Okay? So as long as we're occupying the same place on the figures, then they're corresponding. So let's look at, we'll look at some of the corresponding sides. So now I'm going to highlight a pair of corresponding sides. So maybe I'm in the middle of the H in the top bar. So then if I want the corresponding part of that, I have to go to the top bar in the little h, like that. And if I wanted to do, let's do blue, let's make this even a little thinner. If I want to maybe highlight this bottom part, the bottom left part of the H, then I'd have to go over here to the bottom left part of the H on the smaller figure, and those would be corresponding. Okay, hopefully that makes sense. Let's go back to this problem and we'll look at part B. So what scale factor takes the original from the original bigger one to the smaller one? So we have to think about, okay, what are we multiplying by? And when we think multiplying by, what are we multiplying the side lengths by to get from the bigger to the smaller? And you can't really see the grid on this, but you can hopefully see it on yours. And if I look at the left-hand side of the big figure, I've got let's see here, 1, 2, 3, 4, 5 grid marks. So that's 5, that side. And on the top, I've got 1, 2, 3, 4. So this is 4. And in the middle, I've got 1, 2, 3, 4. This is 4. And over here, I've got 2. 1, 2. Okay, so I'm just going to look at each of those numbers, and I'm going to see how they compare to the smaller figure. So it looks like on the smaller figure, I've got 1 here. In the middle, I've got 1. Over here, it looks like I have a half, like it occupies half of a box. And then up and down vertically here, this looks like it's 1 1/4. Not quite sure, but I'm thinking it might be 1 1/4, which, as you know, hopefully is also 5/4. Okay, so if I go down here to do some work and think about this, I know that 5, my side 5, goes to 5/4. My side of 4 goes to 1. Both my sides of 4 go to 1. My side of 2 goes to 1/2. And that's it. The rest of the sides are all the same. Okay, so I'm thinking, okay, what do I have to multiply by in order to go from 5 to 5/4, 4 to 1, and 2 to 1/2? Well, it looks like if I multiply 4, if I divide 4 by 4, I get 1. So if I multiply 4 by 1/4, I'm also going to get 1, right? So 4 times 1/4 equals 1. right? Because remember, 4 is just 4 over 1, and we multiply straight across. So then we get 4 over 4, which is 1. Okay, so that checks out. So let's go back. I'm going to write in this space up here just because it gives me a little more room. If I multiply 5 by a fourth, do I get 5/4? Well, let's see. If I have 5 over 1 and I multiply top to top, bottom to bottom, I have 5 times 1 on the top, which is 5, and then 1 times 4 on the bottom, which is 4. So that also checks out as 5/4. How about 2? If I multiply 2 by a fourth, am I going to get 1/2? Well, let's see. So 2 over 1, I have 2 on the top, and then I have 4 on the bottom, which equals 1/2. So that checks out. So my scale factor for this particular problem is going to be 1 over 4. Okay, so that was the scale factor for that one. A little tricky. All right, let's try the next page. So here, on number 2, we've got the larger figure on the right below is a scaled copy of the smaller one on the left. Select all the statements that must be true. And it talks about figure B and figure A. We'll just call the smaller one figure A and the bigger one figure B. It wasn't labeled, which is unfortunate. So figure B is larger than figure A. That is definitely true, so I'm going to circle that. Figure B has the same number of edges as figure A. Yeah, it definitely does. If it didn't, it wouldn't be a scaled copy. It would look like a different shape. So it has to have the same number of edges, and edges, again, are the sides that make it up. Figure B has the same perimeter as A. Well, you can see from the picture that these sides in figure B are much longer than the corresponding sides in figure A. So that can't be true. I'm not going to circle that one. D, figure B has the same number of angles. Well, that has to be true. They have to have the same number of angles, otherwise you'd have a different shape completely, right? If you had, this one has 1, 2, 3, 4, 5 angles. Actually 6, but this is a weird angle. And if any of those angles, if there's one more, it would, again, cause a different shape. You'd have like some weird wing out here or something. Okay, so we don't want that. Okay. And then finally, figure B has angles with the same measure as figure A. And that's a tricky one, but that actually does have to be true. They have to have the same angle measure, because if like angle W was a lot wider than angle E, again, it would change what the figure looked like, and it wouldn't be considered a scaled copy anymore. Okay, let's look at number 3. Number 3, we're looking at these two figures, these two polygons, and we want to know what the scale factor is from polygon A to B. So we're going small to big, so we're going to be multiplying by something to get us the bigger thing. So when we go from big to small, like in number 1, we're multiplying by a fraction. When we go from small to big, we're going to be multiplying by just an integer type number, a whole number. Okay? So with this one, I'm only given this side 2.5 and 5. Those are the only corresponding sides I'm given, and we have to look at corresponding sides. These I don't know yet, so I can't use them. But I know it's a scaled copy. So I know that I have to be able to take 2.5, multiply it by something, and get 5. I have to be able to do that. And hopefully you realized that that was 2, that 2.5 times 2 is 5. So the scale factor for this is 2. Okay? In B, we're finding the missing length of each side. So we're going to use the scale factor to find the other lengths. So if this side is 2.5 and the scale factor is 2, then this side has to be 2.5 times 2 again, which is 5. So that's that missing side. If this side is 1.5 and we have to multiply by 2, then this side is 3, because 1.5 times 2 is 3. Okay. And then finally determine the measure of each angle. And so I referred to this in part 2, that they have to have the same angles. So if this angle here is 53, the corresponding angle up here also has to be 53 degrees. And if this one is 82, its corresponding angle here has to also be 82 degrees. They have to be the same. Okay, cool beans. Let's keep going. All right, this last page, or these last couple of problems are on, this is just some review about multiplication. So just and addition and subtraction, just number facts. So this is asking, what do I multiply by 8 by in order to get 40? Hopefully you recognize that was 5. What do I have to add to 8 to get 40? Hopefully you saw that that was 32. Okay, I'm going to pause because something has happened.